Welcome to Brain Vision.
It says that the upper end of a 3.8 meter long steel wire, so I'm just going to real quick write L equals 3.8 meters. And steel wire is fastened to the ceiling. So let's just quickly set up our problem here. We have a wire fastened to a ceiling, and it has a 54 kilogram object suspended from it. 54 kilogram object suspended from it on the lower end. We observe that it takes a transverse pulse, so a wave that we hit. It takes 0.0492 seconds for that pulse to travel from the bottom of the wire to the top of the wire. And we want to know what is the mass M of the wire. Basically the way we proceed to do this is by noting that the velocity of a traveling wave is going to be the square root of the tension in the wire divided by mu, where mu is the mass per unit length here. And this is an important equation here because we can calculate V here because we've been given the length of the wire and the time it takes for the wave to travel. So we can plug in and solve for V real quick. V is going to be the length over the time here, which is 3.8 meters divided by 0.0492 seconds, which is equal to 77.24 meters per second. All right, now let's real quick write this in a different form. In terms of mu, I can write mu is equal to F over V squared after some algebraic manipulation here, and plug in what we know for the tension here. This is going to be 54 kilograms times 9.8 meters per second squared here, because remember, F is equal to mg. G is 9.8 meters per second squared, divided by this velocity squared, 77.24 meters per second. And that gives us 0.0887 kilograms per meter. But we're not done quite yet, because that's mu, that's the mass per unit length, and we're looking for m, the mass. So you can remember that mu is equal to mass per unit length. So mass is equal to mu times L, and therefore m is equal to 0.0887 kilograms per meter times the length, which is 3.8 meters, which is 0.337 kilograms. And that's all for that problem. Oh, I'm sorry, I miswrote. There should be a 7 there. 337 kilograms. All right.